Well, good morning, Algebra 2. This is lesson 100. Yes, we're finally into the 100s. And our objective for today is how do you graph parabolas? And parabolas are generally in two different forms, so you can get them in either one of these forms decently easily. And the first one is vertex form. And we call it vertex form because we can easily get the vertex of the parabola from this form. And I guess maybe we should talk just real quick about what a parabola looks like. It is kind of a U shape like this, and there is an axis of symmetry that passes through the vertex, and the vertex is that lowest point. They can also be flipped upside down, in which case the vertex would be the highest point. But anyways, we call this an axis of symmetry because if there's a point here, there'd be a point the same distance from that axis of symmetry over here. So that knowing that kind of makes it a little bit easier to graph. So this is the vertex form. This A in front, if this A is positive, the parabola will open upwards. If A is negative, it's going to open downwards. Also, if this A is bigger than 1, it's going to make this parabola narrower. And if it's between 0 and 1, it's going to make it wider, like squish it out this way. This x minus h, if you take the opposite of this, so like right here we'd use 2, and then here we'd use negative 4, that'd be, so my vertex of this one would be 2, negative 4. And that's the vertex is right here, 2, negative 4. And then the axis of symmetry is just x equals h, or x equals 2 in our case. So as we kind of talked about that, let's go ahead and write that down. Vertex is going to be the point 2, comma, negative 4. And again, I got that from in here, the opposite of the one inside and just this one outside, 2, negative 4. I'm going to go ahead and graph that point, where x is 2 and y is negative 4. It's going to be right there. And then the axis of symmetry is going to be x equals 2. I'm going to use the dotted line to represent the axis of symmetry. Remember, x equals the number is a vertical line. And then I just need to go through and maybe plug in 2 or 3 more points so that way I can find out where they're ending up here on this graph. So how about I plug in, well, we already know when x is equal to 2. I'm going to plug in a simple number kind of right there with 0. So let's plug in 0 into that. So I'm going to say y is equal to 3 times 0 minus 2 squared minus 4. Well, 0 minus 2 is negative 2. Negative 2 squared is 4. So this is going to be 3 times 4 minus 4. So this is going to be 12 minus 4, which gives me 8. So notice I plugged in the 0 and I got y to be 8. So that gives me a point where x is 0, y is 8. So I can graph that point right here. And I can also, since it's axis of symmetry, I can also graph a point right here. Since that's to the left, right here, that means I'm going to put one to the right, because axis of symmetry means it's going to be the same on the left and the right. So notice this 3 is going to make this one pretty narrow. Now if we wanted to plug in 1 into that, that might be another decent point that we can just kind of see where the shape of this, how the shape of this is going. So let's say y is equal to 3 times 1 minus 2 squared minus 4. 1 minus 2 is negative 1. Negative 1 squared is going to give me positive 1. So it's going to be 3 minus 4, so it's going to be negative 1. So that means I have the point where x is 1, y comes out to be negative 1. Then I can graph that point. X is 1, y comes out to be negative 1. I can graph this point here. Now I could keep plugging in more and more points if I wanted, like plugging in 0.5 or 3/4 or something like that. But I get the basic idea of the shape, and since it just says sketch, it doesn't say it has to be exactly perfect, I'm going to graph it like this. Put those arrows in the end, and we will be finished. So my vertex, my axis of symmetry, and a sketch of the graph. Alright, now sometimes it's not in what we call vertex form, it's in general form. And general form is probably what you're going to see it in most of the time, where you're in like y is equal to ax squared plus bx plus c. So same idea here with the a, the number by the x squared. If a is positive, it's going to open up. If a is negative, it's going to open down. Axis of symmetry is a little bit harder to find, but not too hard, because, well, you just plug in this number and this number, or the opposite of this number divided by 2 times that number. And then C is going to be your y-intercept, where it crosses your y-axis. So let's see if we can start finding some of this information. First of all, we know that this one's going to be opening up downwards because this number is negative. So let's see if we can find the axis of symmetry. So x is going to equal to negative b, which in my case is going to be negative 3/2, divided by 2 times a, which is a negative 1/4. Well, it's going to be negative 3/2 divided by 2 is in that 1 time, 2 is in that 2 times, so negative 1/2. That's the same thing as negative 3/2 multiplied by 2 over negative 1. Those reduce, and it just gives me 3. So I have x is equal to 3. This is my axis of symmetry. So then I'm going to go ahead and draw that on here, just with dotted lines. I know, well, I guess let's see here, this number right here, 13/4. If I want to change that into a decimal or a mixed number, let's see, that would go into that 3 1/4 times, which is the same thing as negative 3.25. So negative 3.25 is going to be right here. That's 3 to the left, so I'm going to go 1, 2, 3 to the right and put a point there as well. And now let's see about plugging in some numbers. I'd kind of like to find out where the vertex is. To find out where the vertex is, I need to plug this number in for x. So let me go ahead and just box this in here because that's one of my answers. So I need to plug 3 in for x and then see if I can solve this. So for y, so I'm going to say y is equal to negative 1/4 times 3 squared plus 3/2 times 3 minus 13/4. So it's going to give me negative 1/4 times 9. I'll say 9/1 just so I can simplify this easier. Plus, this is like 3/1, so I'm going to say 9/2 minus 13/4. So this is going to be negative 9/4. I'm trying to get all this denominator the same, so I'm going to multiply this one by 2/2, which would give me plus 18/4 minus 13/4. So let's see, 18 minus 9 is 9, minus 13. So 9 minus 13 is going to give me negative 4/4, which is just negative 1. So that's my x coordinate. So this is going to be my vertex. My x is 3. My y is -1. So 3, -1. Here's my vertex. Alright, I think I might just do one more number. I'm going to try -2, or you could try 8. It'll get you the same answer, right? Because notice -2 is 1, 2, 3, 4, 5 to the left. This is 1, 2, 3, 4, 5 to the right. So you get the same answer, and -2 is a little bit easier to work with, so I'm going to try the -2. Y is going to equal to -1/4 times -2 squared plus 3/2 times a -2 minus 13/4. Now I simply picked 2 because that would hopefully reduce with my denominators and make my life a little easier. So this is -1/4 times 4/1. This is going to be -6/2 minus 13/4. Same idea here, multiply this by 2/2. And I will get -4/4. I know that reduces, but we're just going to stick with it for now. Minus 12/4 minus 13/4. Since they're all negative, I just need to add those numerators. It's going to be 25, 26, 27, 28, 29. -29/4, which is the same thing as -7.25. So then at -2, I'm at -7.25, which is right here, approximately anyways, and then I can do the same over here at 8. That gives me a good shape of what this is going to look like. So I can draw it on like that. I've done 2/10 of your homework, so you should know once you get less than 20%. Go ahead and finish these out, ask questions as you need to. Good luck, guys.